Today, we're going to dive into a really common and sometimes costly mistake that a lot of us make with averages. And we're going to do it with a story about two shopkeepers, a wild market, and a surprising little math twist. So let's set the scene. Our story starts in this bustling little market where we meet our two ambitious shopkeepers, Ravi and Mira. Their shops are right next to each other, and, they're both working hard to make it big. And in the beginning, things were going great. Business was absolutely booming. In their very first year, they each saw their shops grow by a whopping 50%. Life was good. But as you know, markets can be pretty unpredictable. The next year, that boom turned into a bust, and both of their businesses fell by 50%. And this is where a huge miscalculation comes into play. So while Mira was pretty worried, Ravi, he seemed totally unfazed. He just figured, hey, a 50% gain, then a 50% loss. That averages out to zero growth, right? It sounds logical. Plus 50, minus 50, they should just cancel out. But this is exactly where our story takes a very interesting turn. Let's actually look at the numbers here. Let's say Ravi started with a nice round 100 rupees. That 50% growth in year one, great. That brings him up to 150. But here's the catch. The 50% loss in year two is calculated on that new total. Half of 150 is 75, which means he's now left with only 75 rupees. Wait a minute. He started with 100 and ended up with 75. That is absolutely not zero growth. It's a 25% loss. Ravi has just walked right into what author Sam Savage calls the flaw of averages. He used a simple average for a situation that's actually way more complex. So just as Ravi is standing there scratching his head, this wise old math teacher, who happened to be a regular at the market, overheard him. She explained that he was looking at the whole problem the wrong way and offered to let him in on a little secret. And the teacher's secret is actually pretty simple, but it's a total game changer. Growth rates that compound over time, they're multiplicative, not additive. You can't just add and subtract the percentages. A 50% gain really means you multiply by 1.5, and a 50% loss means you multiply by 0.5. To find the real average in situations like this, she explained, we need a totally different kind of tool. And that tool, the hero of our story, is called the geometric mean. It is specifically designed to figure out the true compounded growth rate over time. So let's put these two side by side. Ravi used the simple arithmetic mean, the one we all learn in school. Add up the values, then divide. But for these compounding numbers, you need the geometric mean. That's where you multiply the growth factors together and then take the root to find the true average. Okay, so how does this secret method actually work in the real world? Let's apply the geometric mean to Ravi's business and find out what his actual average annual growth, or in this case, loss, really was. All right, here's how you do it. First, you turn the percentages into multipliers. A 50% gain is 1.5, and a 50% loss is 0.5. Then you multiply them together, which gets you 0.75. Since this happened over 2 years, you take the square root, which is about 0.866. Finally, you subtract 1, and you get negative 0.134, or a negative 13.4% growth rate. And this chart just shows the difference so clearly. Ravi thought he was breaking even at 0%, but in reality, his business was effectively shrinking at an average rate of 13.4% every single year. That is a massive wake-up call. Now, you might be thinking, okay, that's a neat little math story, but why does this actually matter to me? Well, this isn't just about shopkeepers in a fairy tale. This concept is absolutely crucial for understanding some of the most important numbers in our own lives. The geometric mean is like the secret engine that accurately calculates long-term investment returns, which you might know as the compounded annual growth rate, or CAGR. It's also used all over science to measure stuff like bacterial growth or in population studies. Basically, anywhere that change multiplies over time. Just look at this incredible real-world example from the stock market. Using data from 1926 to 2006, the simple arithmetic average return was 12.34%. If you use that number, you'd think a $1 investment would have grown to over $12,000. But the actual value? It was just over $3,000. And guess what? The geometric mean, at 10.42%, predicted that final amount perfectly. We're not talking about a small rounding error here. We're talking about a thousands of dollars difference. So the big takeaway here is really simple. The next time you're looking at investment returns, growth rates, or really any number that compounds over time, just remember Ravi's story. Don't fall for the flaw of averages. Because if life compounds, your average should probably compound too.